All right. Question number 5 asks to evaluate the line integral where C is the given curve, and then it gives us some parameters. So I'm just going to write it out here so it's a little bit more clear. But it's saying that the function is x of y, and this is representing the curve C. It also gives us that x is equal to t squared, y is equal to 2t, and t is within the bounds of 0 to 1, okay? And ultimately, it's asking us to evaluate the line integral. Okay. We know that the line integral, the line integral is defined like this. We have integration for the curve C, that's what that little C means, for the function by ds, that is where ds is equal to square root of dx by dt squared plus dy by dt squared dt. So dt is outside of this square root. Okay, so if we want to evaluate the line integral for this function, the given function of x times y, we need to determine what the derivative of x with respect to t is, and what the derivative of y is with respect to t, so that we can sub them all in. All right, so let's start off with x. We have x equals to t squared. So taking the derivative, we have dx by dt is equal to the derivative of t squared, and that is just 2t using the power rule. And then we also have y equals to 2t, and the derivative of that, taking the derivative of each side, we have the derivative of y, well, I guess I don't need to write that again. Derivative of y with respect to t is then just 2. That's taking the derivative of 2t on the right-hand side. Okay, so now that we have the derivatives here and here, we can sub that in to the full equation for the line integral. So I'll just rewrite it here. Integrating over the curve C, we have our function by ds. That is equal to, I'm just going to write in the given function. So our given function, subbing in for this portion here, is x times y. That's what I wrote up here, right? So that's x times y. And then for ds, remember we have to sub in our definition here of what ds is. So that's the square root of, I'm just going to keep this showing so you can see. Hopefully they're not cutting it off. We have the derivative of x, which is 2t, found up here, squared, plus the derivative of y, which we found here, to be 2 squared by dt. Okay? But we have to remember about the bounds, okay? Here it's undefined. It's just stating that it's over the curve C. But on the right-hand side, we have to define what those bounds are. because we're taking the integral with respect to t, we need to find the bounds with respect to t as well. And in the original question here, it states that t is within the bounds of 0 to 1. So that's what we're going to be integrating by. So t equals to 1 on top and t equals to 0 on the bottom. Okay. I'm just going to also sub in x and y here so that everything that we have being integrated is with respect to t. Makes it easier for us. So, well, we don't have to write the t equals every single time. I'll just write 1 and 0. And we also have, remember, x is equal to t squared, and y is equal to 2t. I'm also going to kind of expand this portion here. So we have 4t squared plus 4 by dt. Okay, so when we expand this part, it's just 2t cubed. Just going to rewrite this. Now that we have everything expanded or written, basically simplified, we have to start kind of rearranging it. Actually, there's one more thing that we can do to simplify this even further, is we can factor out. We can see that there's a 4 here and a 4 here. If we factor those out, we might be able to make it a little bit simpler for ourselves. So we have, I'm just writing out in a lot of steps so that you can see exactly what's going on here. Actually 1 dt. Yep, and we know for square root of 4 is just 2. So writing this again, we have 2 times 2 is 4. Okay, d squared plus 1 dt. Okay, now that we're at this step, we have to figure out how we are going to take the integral of this. So, in order to take the integral of something like this square root, the term under the square root here, we are going to do a substitution, okay? I'm going to say let u equal to t squared plus 1. So that's everything here underneath the square root. If you rearrange that, we're going to play around with that a little bit so that we're able to sub in u for t, for this t, u for t under the square root here, and then we also need to replace the dt with a du. So everything will be respect to u instead. We also have to remember to change the bounds because remember this is equal to t and this is equal to t. We have to replace those as well. I'm just going to do that one afterwards. So yeah, I wanted to say u equal to t squared plus 1. You can also rearrange that and say that t is equal to the square root of y minus 1. You have to take the derivative of this, which you'll see why later, just so it can be subbed in for dt. So take the derivative of both sides. We get du by dt is equal to 2t, because of course, remember the derivative of 1 is just 0. So rearranging, we have du equals to 2t dt. Okay, so we have a few different components here that we can use. We have this, we have what t is equal to, and we have what du is equal to. All right. So working with this equation, going back to this, we have, oh, remember to change the bound. So originally we have t is from 0 to 1. So that's what we're going to use this equation for. Nope, that's not true. That's what we're going to use this equation for. So to find the bounds, we are going to say that, so this is going to be u equals to something new and u equals to something else. So for the top bound, we have u equals 2, and then for t, before we had 1 squared plus 1, and that is just 2. So u equals to 2. And then on the bottom bound, we have u equals to, and for t, we have 0 squared plus 1. So that just means u equals to 1 on the bottom bound. So change the bounds. Now we have to rearrange. Well, I'm going to write it, I think, under here, just so that we can see it separated a little bit. Yeah, because it's before we change it to u, we need to sort of move things around. So we have 2t squared. All I'm doing is separating this 4t cubed term. So it's a little bit easier to see what we're doing. So taking out a 2 and a t from the 4t cubed, and I'm just moving it to the back. Now that looks familiar. This, it's a little bit squishy in here, but this term is, remember, this term. So that can be subbed in for du when we get there. But first, I'm going to tackle this 2t squared. Oh, hopefully I'm not cutting that off. 2t squared term, right? So 2, and then if we're subbing in t squared for this t that we found here, we have square root of u minus 1, and square that. If we remember, we're saying this is t, so we need t squared, times underneath the bracket, instead of t, or not bracket, sorry, square root, instead of t squared plus 1, remember we said that we wanted to let u equal that. So we just have the square root of u. And for replacing the 2t times dt, we created this du term. Right? Hopefully that makes sense. So we have all new bounds for u. We substituted all the t's with u's, and now we are ready to, well, after rearranging, we'll be ready to take the integral. So the square root of, or the square of the square root will just be u minus 1. We also have square root of u by du. I'm just going to keep this in the brackets to keep it separate. Okay, and let's just distribute this into the brackets. And at the same time, I'm going to take out this 2 since it doesn't need to be integrated. So we have 2 times the integral from 1 to 2. And then distributing the square root of u into the brackets, we then get u 3 over 2. Because remember, square root of u is equal to u to the exponent of 1/2. So distributing into the bracket will give you u to the power of 3 over 2 minus u to the power of 1/2 du. And now we have a simple integral to do here, okay? It's just using the reverse power rule, which I guess I'll write here so it's a little bit more clear to see. we have, oops, reverse power rule, which states that the integral of x to the power of n by dx is equal to xn plus 1 over n plus 1 plus, well, usually a constant if the boundaries are undefined, but in this case we have defined boundaries, so we don't need to include a constant. So as I do this integral, if it's not clear to you exactly how I got everything, if you want to write it out in this format with by writing out n plus 1 as the exponent plus 1 instead of just going straight to the next step, then maybe that'll make things a little bit more clear for you. But basically, from the step up here, I'll probably run out of room. From the step up here, we can get that the integral is, put it in one big bracket, u 5 over 2, 5 over 2, and we are going to evaluate that from 1 to 2, and subtract or minus. What I'm basically doing here is taking the integral of each one separately and evaluating them separately rather than all at once, just because it seems a little bit more clear to me. And then for the next one, we have 3 over 2 divided by 3 over 2 evaluated from 2 to 1. Okay? So, yep, don't forget that the 2 is out front, and that will multiply everything within the brackets because we took that outside of the integral a little bit earlier. All right, so what I'm going to do now is evaluate and basically replace the u's with 2 and 1. So 2 times everything. We have first we replace the u with a 2. We have 2, 5 over 2 divided by 5 over 2 minus 1, 5 over 2, which we can kind of just ignore because 1 to the power of anything is still 1, divided by 5 over 2. So that's just evaluating this first term. And now we're going to evaluate the second term, so replacing u with 2. 3 over 2, 3 over 2, minus 1, and remember this is a 3 over 2, but we don't need to write it, divide by 3 over 2. Alright, there's not too much we can continue to do here, just simplifying, but we basically solved it. It's up to you if you want to leave it the exponents in a fraction form, or if you want to change it back to a square root form. And I'm just going to move the 2 from the denominator because it's a fraction in a fraction. I'm just going to simplify that a little bit. So we've got 2 times square root of 2 to the 5 under a square root divided by 5 minus 2 divided by 5. That's just rearranging this fraction here and flipping the 2 up on top, minus, well, I guess I can distribute this minus as well into the bracket, so we don't need those extra brackets there, and we get minus 2, well, square root of 2 cubed divided by 3, well, I forgot about the 2 here. Let's just put that on top as well. Alright, minus 2 over 3. Okay, now that we're at this point, if you want, we can find a common denominator, which lowest common denominator here is just 15. And we can also, well, I'll just rewrite the top here, numerator. minus 2 minus 2. Oh, I messed up the sign here because we distributed the minus sign, remember? That just will change to positive. 2, 3 plus 2. Oh, I forgot to change every coefficient here. So in order to change that to a 15, we need to multiply it by 3. Can't forget. Minus 6 minus, and then for this one, to change it to a 15, we need to multiply by 5. So we have 10 plus 10. Alright, now that we have this, of course you can just add these two together, but I'm just going to go straight to the final answer. If this is a calculus class, you might not be able to use a calculator, but if you are, then the final answer is 1.2876 rounded off. Alright, and that is the final answer. In this solution, they leave it as this final answer. The step right above is basically the same as what we've got here. So I'm going to say, oops, good work. Well done. Well done. And that's all we're going to do for today. If you found this helpful, please leave a like. And if you want to be notified of when we do another Q&A, please hit the subscribe button and hit the notification bell. If you want to submit any of your own questions, you can see the links in the description below or just leave a comment. And that's all for today. Thanks for watching.